So we have a 7.50 kilogram crate is pulled across the floor with a horizontal force of 25.0 newtons. The crate accelerates at 1.50 meters per second squared. What is the friction force on the crate? The first thing we do when solving problems is identify all the information that's given, and diagrams are an excellent way to help identify this information. So what we have is a crate that's on the floor. So this is the crate, our diagram. We identify all the forces that are acting on it, which is a free body diagram. We know that there is a horizontal force, we'll say to the right, call that the applied force, and that applied force is 25.0 newtons. The other forces that are acting on the crate are, of course, the force of gravity, which is always down, and we have the normal force that's acting on the crate that is up. Since we know there is a friction force, the friction force is always the opposite direction of motion, so the friction force will be to the left. So this is the force of friction. Since we have forces that are acting in different directions, we identify to the right is positive, to the left is negative, up is positive, and down is negative. Always identify the direction of the forces in your diagram. Other information that we have, we know that the mass of the crate is 7.50 kilograms, and we know that the acceleration is 1.50 meters per second squared. That's positive, so it's in the positive direction or to the right. We want to identify now what we're solving for. In this case, we want to determine the friction force that's acting on the crate. So this is what we're trying to solve for. And in order to do this, we have forces and acceleration. We know that the summation of forces, since the only motion is in the x direction, we can add up all the forces in the x direction, which are going to be the applied force plus the friction force. We also know that Newton's second law of motion states that the net force is equal to mass times acceleration. A big indication of information you're given when you have mass and acceleration, kind of like a little bell should go off in your head. Whenever you have mass and acceleration of an object, you can automatically determine the net force by Newton's second law. So now we can determine that net force. So net force is equal to the mass, 7.50 kilograms, times the acceleration of 1.50 meters per second squared. We solve for that net force, we should get 11.3 newtons. Remember, the net force is the same as the summation of forces. So we now know the summation of forces. We know that the summation of forces, which is the net force, is 11.3 newtons. And we know the applied force is 25.0 newtons. And then plus the friction force. So we've taken this equation, put in the values for the forces that we know. Since we're solving for the friction force, we solve this equation for friction, subtract 25 newtons from both sides of the equation, and we should get a friction force equal to negative 13.7 newtons. It's negative, which is correct because it's in the negative direction. So we have a negative 13.7 newtons for the friction force.